The impact of the presence of man and of today's society is clearly visible in nature. Industry, with its waste, residual waters, and refuse from our cities, seriously harm the ecosystem in which, in other ages, the term waste did not exist. But we live in a society in constant development, in a society where well-being is synonymous with life, and where consumer fashion prevails, that is to say, in a society of waste. All this brings about a rupture in the ecological equilibrium. The materials we call waste cannot reproduce the complete cycle, and we are confronted with the serious problem of the enormous volume of waste we generate daily. This situation becomes clear in a large city like Madrid, which generates some 3,400 tons of waste daily. Expressed visually, that amount would be enough to fill the Santiago Bernabéu football stadium to a height of 30 meters in less than 1 month. The appropriate treatment of household waste, called municipal solid waste, MSW by the experts, is one of the challenges that developed societies have to face at present if they want to preserve their environment and guarantee its quality to their citizens. The management of MSW demands immediate, realistic and efficient solutions. Solutions that have to be based on the one hand on progressive social conscience and collaboration, and on the other, on the use of the most modern and guaranteed procedures developed for that purpose by present-day technology. To encourage the separation of recyclable packaging in every home and their deposit into selective containers for collection is one of the most suitable ways of obtaining appropriate, high-quality material for its subsequent recycling. Nonetheless, of the 3,400 tons of MSW which are generated daily in the city of Madrid, only some 200 tons are collected as separated recyclable waste, and so an integral management system is needed to give a global response to the MSW problem. With this objective, the idea arose of an installation that would allow the complete management of MSW, creating the Integrated Municipal Solid Waste Treatment Center, Las Lomas. After having been awarded through public tender to TIR Madrid, the construction of the center started in April 1991. Las Lomas represents the first experience of integral MSW treatment carried out in Spain. The center works in 2 phases. During the first phase, materials like glass, plastics, scrap metal, paper and cardboard and aluminium are recovered and subsequently sent to be recycled by specialized companies. Also during this phase, the food debris contained in the residues is transformed into a product for field fertilization, called compost. During the second phase, the energy contained in those non-recyclable combustible residues is recovered through their incineration. The center can treat 1,200 tons per day of MSW, which represents a volume of about a third of the total amount of waste generated in Madrid. The process starts when the lorries that collect the MSW arrive at the center, where they are weighed before dumping their contents into the reception pits. Bridge cranes deposit the residues into 4 hoppers equipped at their bases with 4 plate feeders, whose function is to provide a continuous flow rate to the treatment lines. From these lines, the operators remove glass, oversized objects, and large cardboard and plastic wrappings. Afterwards, the residues are sifted in 4 rotating sieves, separating them into 2 parts, bigger and smaller than 10 centimeters. The part smaller than 10 centimeters is fed to the conveyor belts. After manually removing the glass bottles and the aluminium containers, as well as ferrous metals such as tins and cans by means of a magnetic separator, the rest of the residues, which usually are food residues, for example organic matter, go to open aerobic fermentation tanks where they are periodically turned over for proper oxygenation and fermentation. The fermentation area is covered in the part corresponding to the first weeks of fermentation. In this part, the air is extracted by means of powerful fans that draw the air to the biofilters where the odor is removed. In the same way, the leachate pools, where the leachate coming from the fermentation area is collected, are covered, and the air is treated in their biofilters. After 8 to 10 weeks, when the organic matter has been reduced to compost, or rather to organic fertilizer, the separation continues by means of densimetric sieving in 2 refining installations of the remaining glass and other inert elements, obtaining on the one hand the waste of the process that will go to landfill, and on the other hand the purified compost usable as fertilizer that will be stored until distribution. Of the residues larger than 10 centimeters, the separation of those products that are suitable for recycling is carried out manually, mainly plastic, cardboard and aluminium containers. In addition, all ferrous metals are recovered using electromagnetic separators. Afterwards, all the products which are thus obtained are compressed, packed and transported to different companies to be recycled. But even after all these selection processes, there are still some remnants left, called the combustible waste fraction, which, although containing no recyclable material, still does have some calorific and energetic value. At conventional recycling plants, this waste is dumped in landfills. In this center, it is used as a high calorific power fuel for the waste-to-energy plant. The waste-to-energy plant at Tir Madrid has been designed and constructed with the most up-to-date technology, so that a perfect combustion of the non-recyclable residues generated during the first part of the process can be obtained. This plant consists of 3 lines, each one with a fluidized bed furnace, 1 heat recovery boiler and 1 gas cleaning plant. The steam produced in the 3 boilers is taken to a turbine, where the electric power is produced. The chosen combustion system is that of a fluidized bed, which is presently the most appropriate for the treatment of the combustible waste fraction derived from MSW. Inside the furnace, the sand is being fluidized. This fluidization is achieved by injecting air through nozzles installed at the base of the furnace, whereby the strong movement of the bed sand is attained. This boiling action causes turbulence and favors the blending of the hot sand with the waste, acting like millions of hot points and achieving a perfect combustion of the waste thanks to the controlled entry of air. At the bottom of the furnace, ash mixed with the sand is extracted, filtered and returned to the furnace. The fireball that can be observed is produced by the combustion of the waste, which generates the hot gas which is fed into the post-combustion chamber. Inside this chamber, in compliance with the current European regulations, a minimum temperature of 850 degrees centigrade is reached. To guarantee the combustion conditions, the installation is equipped with various thermocouples located inside the post-combustion chamber, which ensure the correct temperature of the gas. The installation is also equipped with 4 auxiliary burners per furnace, used during startup to heat the fluidized sand so that the temperature in the post-combustion chamber reaches 850 degrees centigrade. In each line, gas from the furnace goes through the heat recovery boiler, which produces 41 tons per hour of steam at 47 bar and 425 degrees centigrade. The steam from the 3 lines passes into the turbine hall and goes through the turbine, which has a power of 29 megawatts. This electric power is equivalent to the different consumptions, domestic, municipal and industrial, of a town of 50,000 inhabitants. The cold gas coming from the boiler passes to the gas cleaning plant. Each line has one pair of cyclones, a semi-dry absorber, two active carbon injectors, one baghouse filter and a catalytic reduction system to reduce nitrogen oxides. The larger particles are retained inside the cyclones by centrifugal processing of the gas. After passing through the cyclones to the semi-dry absorber and with the objective of neutralizing the acid gas, a rotating atomizer is used to inject atomized calcium hydroxide. Each line has been equipped with two active carbon injection devices to avoid the emission of dioxin and furane to the atmosphere, installed after the absorber and before the baghouse filter. The gas, after passing the carbon-active injectors, passes through a baghouse filter where the smaller particles are retained, and then proceeds through the catalytic reduction system in which nitrogen oxide is eliminated. After having been perfectly cleansed and purified, the gas is driven to the stack by means of an induced draft fan. The plant is equipped with facilities to allow the collection of the two different types of solids that it generates: the slag coming from the furnaces and the flying ashes coming from the boilers, cyclones, absorbers and baghouse filters. The bottom ashes have been characterized in accordance with current legislation, being classified as inert waste. The flying ashes are deposited in the security landfill that is close to the plant, and which was designed specifically for this kind of waste. Samples of the gas emissions are taken in the chimney itself. These samples are taken to an analysis center, where the compliance with the prevailing legislation regarding gas emissions is continuously checked. This record is always kept in the control room, and at the end of each month is sent to the City Council of Madrid, as well as to the Environmental Protection Agency of the Community of Madrid. The union of the most modern and effective waste combustion system with the complete gas treatment plant has managed to keep the emissions of polluting agents to the atmosphere far below the values of the prevailing legislation. In addition, the emissions of dioxins and furanes are also well below the limit of 0.1 nanograms per normal cubic meter of gas, which is the established limit for these types of compounds. The separation at source in the homes of the citizens. The deposit in special selective disposal containers. The separation at the center itself of those materials capable of being recycled. The post-recycling product. The production of compost from the organic matter. And the recovery of the energy contained in the combustible waste fraction are inherent parts of an integral management program of urban solid waste, whose efficiency depends on the effort and the cooperation of all involved. The Madrid City Council's policy for waste management stands along these lines, at the forefront of other treatment systems for urban solid waste, to provide the best guarantees for the preservation of the environment. Fundamental to this policy is the Integrated Municipal Solid Waste Treatment Center, Las Lomas.
Thank you.